Hello everybody. We're going to go ahead and we're going to talk about array lists. Now, a question I often get asked when talking about collection types in C#, like arrays and lists and dictionaries, is what about array lists? Can I use them? Should I use them? What's the difference? Generally, my answer is simply they are deprecated and don't use them. For most people, this is acceptable. If something is deprecated or considered as such, then why should I learn it or care? However, wanting to know what it is and why it no longer is considered a standard use item is important sometimes. So first, let's do a refresh. Now, you have arrays. Arrays are fixed size collections. They are strongly typed. Meaning they may only contain values of the type they were initialized with, i.e. in this case an int, or if you were to do a string array, or an array of a particular object. Because they are a fixed size, such as 5, okay, you can only change the values they contain at each index. In this case, I have an int array, okay, so therefore I have an array that can hold ints. It can hold 5 of them. I can go ahead and I can change at each index 0 through 4 what int value is there, but no matter what, I have an int array of 5 indexes. I cannot add or reduce that. Okay? Now, lists, on the other hand, are dynamically sized collections. Okay? They're also strongly typed, though. Let's go ahead and because I can go ahead and I can add and remove items at will. I don't have to go ahead and give it a size, the int list, when I go ahead and instantiate it. I can simply say int list.add, and I'm going to add a 5, or int list.add and 33. Okay? Likewise, I can go ahead and int list.remove 5, and now it's going to go ahead and removes the first occurrence of a specific object from the list. So it's going to go through my list, find the first occurrence of 5, and remove it. Okay? And my indexes will change automatically. They will be rebased based upon the number of items in my list. So as I add and remove, the indexes change. Likewise, you can also go ahead and at a particular index, which is 0, equals 900. So not only can I do what I can in an array, which is to go ahead and change a value stored at a particular index, but I can go ahead and add and remove indexes from a list. Now, this right here is the main difference that people go ahead and think about when looking at arrays versus lists. Okay? Let's go ahead and let's clear this out of the way. Array lists, on the other hand, they were an in-between for arrays before lists were added to C#. They contain many of the advantages of lists, but they're not strongly typed, meaning they can have an array list with int, strings, or other objects all mixed into one array list. Now, you write an array list by using the type ArrayList, and we'll go ahead and use the variable name ArrayList equals new ArrayList. Now, with an array list, you do not go ahead and define a type. Okay? You can go ahead and add whatever you want to the array list, and it's going to store it as an object. Now, object is the base class of C#. Everything ultimately is derived from object. I could add an int, I could add a string. It doesn't care. It doesn't see this as an int. It doesn't see this as a string. It's going to convert them to an object, to the base data type of C# and store them in this array list. Now, obviously, this has some drawbacks. If an array list contains values and you can't guarantee what type they are, you can't guarantee your code will run as intended. So let's go ahead and consider this example. I have an array list with 2 integers in it. I then define an integer. Do int x equals 0. And I go ahead and I create a for each loop. For each item in array list, I'm going to do x plus equals the item. And then we'll go ahead and console.writeLine x, just so we can see this. Now, first, I can't use var for my for each. The problem here is that I cannot go ahead and add to an integer an object. They are incompatible. It doesn't know, it being the compiler, that when I loop through my array list, that I'm going to have an integer. All it knows is that stored within this collection that I'm looping through is an int. Now, if I were to go ahead and I were to change the var to int, I would be saying that I'm going to perform basically a cast as I'm looping through array list. And anything that it encounters should be treated as an integer. Now, because it's an object, it's fine to say, okay, let's try to cast these over to an int. If each item in the array list is treated as an int, it can then be added to x, which is also an int. And if I were to run this code, see, it gives me the value of 8, which is what I expect. 5 plus 3 is 8. Now, if you go ahead and consider this example, I'm just going to copy this here so that everyone can see it. In this case, I defined an int array, and I gave it a couple values. Okay? I then created a new integer starting at 0, just like I did with the x here, and then I did a for each loop. In this for each loop, I said var for item. Now, this is acceptable because the precompiler is seeing it that, hey, vs is an int array. It's an array, so I know everything in it has to be of the same type. It's been defined which type that is, so I know these are integers. So even though I'm using the var keyword, the precompiler knows var is going to be an int. So this is okay. Now, that right there is one of the major drawbacks about array lists. Because you're not strongly typed, when pulling anything out of an array list, you have to cast it back to its original type. Anything that goes into the list is reduced to a basic object. Okay? Again, 5 and 3 are not stored in array list as integers. They're stored as an object. That's why by changing the var to an int, I'm performing basically a soft cast to say, treat these as integers, and it works. Now, let's go ahead and let's add a string to my array list. We're going to add Bob. Notice how there are no errors. I've gone ahead and I've said, treat anything coming out of array list as an integer and add them up here. It doesn't loop through, the precompiler doesn't loop through and say, okay, well, you've got something here that is not an integer. What it's doing is saying, all right, if I'm going to treat anything that comes out of an array list as an int, and that's what item will be, then this code is okay. It doesn't go back and loop through everything. Now, if I were to run this code, I would get an error right there. I cannot cast object of type string to an int. It can't take Bob and convert it to an integer. That's not possible. It's a string. Now, in short, array lists were designed to give you dynamic arrays, but they have since been replaced by lists. The expectation of the programmer is to have to more closely pay attention to them, and the lack of strong typing ultimately made them volatile. Right here, as you can see, this code is totally fine technically. And if I were to use an array list and be adding things that say the user typed in on the fly, I'd have no protection as to what was going into this array list. I could end up with an array list that looks like something like this, integer strings, and then later on I try to perform some kind of arithmetic on it. With lists, you get all of the benefits that array lists were supposed to give C#, but you get the safety of arrays by having them strongly typed. And that is why we no longer use array lists.